2.2 Venn diagrams and subsets. In most discussions, there's either a stated or implied universe of discourse. And what that means is it contains all the things under discussion at a given time. In set theory, the universe of discourse is called the universal set, and it's typically designated by the letter U. And what the universal set is the set that contains all elements being considered in a particular problem or context. In set theory, we also use Venn diagrams. So an example of a Venn diagram in a universal set is as follows. This box right here is our universal set, and it's denoted by U. And within our Venn diagram, we will have a subset that we will call A. Now, all the elements in A are also elements within the universal set itself. Now, the complement of a set is going to be labeled as A prime in this case. And the definition of a complement is for any set A within a universal set U that are not elements of A it's going to be written as A prime is equal to X such that X is an element of the universal set and X is not an element of A. So, for example, if our universal set is the following: A, B, C, D, E, F, G, H, and we have set M equal to A, B, E, F, and set N equal to B, D, E, G, and H. M prime would be any elements of the universal set that are not in M. So in the universal set, we have A, B, C, D, E, F, G, H, and in M, we have A, B, E, F. So M prime would be C, D, G, H. Because remember, the prime of that set is anything within the universal set that is not a member of that set itself, right? And similarly for N prime, it's going to be A and F, A, C, and F. Because remember that N contains B, D, E, G, H, and our universal set contains A, C, and F, which is not an N, so N prime would be ACF. We then look at subsets and proper subsets. So say we are given the universal set of 1, 2, 3, 4, 5, and we have A, which is the subset, which is A, which is contains the elements 1, 2, 3. Because every element of A is also an element of the universal set, A is called a subset of U, which is denoted by this symbol right here. If A is not a subset of U, it would be written as A is not a subset of U. And let's look into the proper definition of a subset. A subset of a set is as follows. Set A is a subset of set B if every element of A is also an element of B, and it's written as A is a subset of B. Now let's look at a couple of examples to see if one set is another subset of another. So these are the two symbols that we're going to be using. If it is a subset, we're going to use this. If it's not, we're going to use this. So let me write down a couple of sets. Now, let's look at the first example. We have 3, 4, 5, 6 in the first set, and 3, 4, 5, 6, 8 in the second set. Now, because every element of the first set is also an element of the second set, it's going to be a subset. Let's do this in a different color. It's going to be a subset. Now, let's look at the second example. We have 1, 2, 6. In the second one, we have 2, 4, 6, 8. Well, we have a 2 and a 6 in the second set, but not a 1. So it's not going to be a subset. Now, say we want to look at set equality, and A and B are sets. If A is equal to B, then we know A is a subset of B, and B is a subset of A. So if you want to look at another definition of if two sets are equal, you can look at if A is a subset of B and if B is a subset of A. If those are both true, then A is equal to B. Now we look at proper subsets. A proper subset is as follows. Set A is a proper subset of set B if A is a subset of B and A is not equal to B. If this is the case, then it is written as A is a proper subset of B. So if we look at it, a subset is going to be written as this with the line underneath, and a proper subset is just going to be this. And this is only the case if A is a subset of B, but A does not equal B. Now let's look at an example. So we have 5, 6, 7. And we have 5, 6, 7, 8. Now we're going to figure out whether we use a subset symbol or a proper subset symbol. If you look at the first set, we have 5, 6, 7. In the second set, we have 5, 6, 7, 8. Now the first set's elements are also in the second set, but they are not equal to each other. So this is going to be a proper subset. If we look in the case of this example, the first set has all of its elements in the second set, and the second set also has all of its elements in the first set. So this is going to be a subset because they are equal to each other. It's not a proper subset because one of them don't equal to each other. It's a subset because they both equal to each other. Now, important thing to note is that the empty set is also a subset of any set. So this will always occur. There will always be an empty set as a subset for any set. So another important case to note is the null set will always be a proper subset of B. And we can move on to another example of where we want to find all the proper subsets of a particular set. So if you have 7 and 8, what are all the proper subsets? Well, we have the null set, we have 7, we have 8, and we also have the set itself as a subset. So in total, we have 1, 2, 3, 4 subsets. If you want to look at the amount of proper subsets, it's simply only going to be the null set, 7, and 8. 3 proper subsets. Now, an easier way to count all the number of subsets and proper subsets is by using this formula. So the number of subsets with n elements will always be 2n. Now the number of proper subsets will be 2n minus 1. Well, why is it 2n minus 1? Well, we need to subtract 1 from this value to obtain the proper number of subsets, because the number of subsets contains the set itself. So if we look at our earlier example, the number of subsets for 7, 8 was 4 because we included 7 and 8 itself. Now the number of proper subsets, you have to remove the set itself, so there's only 3. So we can do an example of finding the number of subsets and proper subsets. So say we have 3, 4, 5, 6, 7. This set has 5 elements. And the number of subsets is going to be equal to 2 to the 5, which is 32 subsets. Now the number of proper subsets is going to be 2 to the 5 minus 1, which is equal to 31 proper subsets. Now, if you want to verify this by listing out all the sets and the proper subsets, you can do that, and you'll end up with these numbers, these values. And so that's what we have for 2.2 Venn diagrams and subsets.